Okay, here we go. I'm recording this video lesson about distance equals rate times time word problems. So just to give you a little background, you guys know this is just a formula. Distance equals rate times time. So for example, if somebody said, hey, I am driving 50 miles per hour down the freeway, and I have been driving for 3 hours, that means I have covered a distance of 150 miles. So distance equals rate times time. You guys have seen this before. In fact, there's different variations. If I took this and I said, I'm going to divide both sides of this formula by r. Let's suppose I did that. Then I have a new formula based on the same concept, but the new formula would be time is equal to the distance divided by the rate. So let's do our problem backwards, our little example. If I know that I have traveled 150 miles, and I know that I was going 50 miles an hour, 150 divided by 50, reduce it, that means I must be driving for 3 hours total. So what we're going to be doing in these word problems is we're going to use this formula, distance equals rate times time, but we're actually going to use it in the form distance divided by rate is equal to time. That's what we're going to do. So I'm going to remove all this stuff that's in my way that I just wrote up here, but that's the underlying concept behind what we're going to do right now. So here's how I work this out. I have 4 word problems here that I just took out of a book that are examples of distance equals rate times time work. And these are chartable problems. We're going to draw a chart to do these. So here's what's going to happen. In problem 1 here, it says a boat goes across a lake and back in 4 hours. Okay, so it starts here, it goes across the lake and it comes back, and the whole time it does that, it takes it 4 hours. The rate going across is 10 miles per hour, but the rate returning is 15 miles per hour. How far is it across the lake? So here's how this is going to work out. I'm going to be asking myself about a distance, a rate, and a time. So I'm going to chart this out. So you're going to see that I filled out all this stuff for you already. So you do not have to take notes really. They're included in the Canvas page. But here we go. I'm going to call it going there, and I'm going to call it coming back, because those are the words they used in the problem. Well, going there, I know I went 10 miles per hour. Well, 10 miles per hour, that's a rate. Coming back, I know I went 15 miles per hour. I know that's a rate. How far is it across the lake? I don't know. That's what they're asking. So I know the distance going there and the distance coming back is the same exact distance. It's not like they moved the lake once I got to the other side. They didn't back the other side up. So going there and back, same distance. Now, here's the deal with T. This is what I want you guys to get into your head here. What we're going to do is we're going to take the formula distance equals rate times time, but we're going to approach it this way. The distance divided by the rate equals the time. So right here, just these two guys right here, the distance divided by the rate. Just these two guys here, look, the distance divided by the rate. So if I say going there, look, I'm going to go there, and I'm going to come back. How long did it take me grand total? It took me 4 hours. So going there, that's what going there looks like. And coming back, that's what coming back looks like. It took me 4 hours. See, everything in my equation is unified by one concept: time. See, in this chart system, we're making this chart. Everything that ends up in the very last column has to do with time. This represents the time it took to go there. This represents the time it took to come back. If I add them together, that's there and back, it took me 4 hours. Now I want to show you guys something really quick here. I'm going to scroll down. I'm going to scroll down quite a ways. When you guys do the word problems for homework, here's the actual assignment. There's 10 questions. There's 10 answers right there at the bottom. There's 10 answers. If you get stuck, what I did is I made up 10 different little individual hints so that you might need to look at my hint if you can't figure out how to start the problem off. But one thing I want you to notice for sure is in a lot of these, I give you the chart and I start you off like, hey, you should be charting all of these problems, and then you can complete the assignment. Now, I know this setup for this problem I just did, all of this is already on Canvas. You could just take a picture of it if you wanted to keep it separate. But I did show you all the setups for these first 4 examples. They're all on Canvas. Anyway, here we go. If I were to solve this, it's a rational equation. Hey, that's the unit we're in. We're talking about rational equations. So I would multiply everything here by 30 because I want to bust the fraction out. And I did not show all of my steps here, but if I do solve it correctly, I get x equals 24 miles. So the distance across this lake is 24 miles. Okay, here we go. We're going to go on to problem 2. Problem 2 is going to once again illustrate that we have a chart in our future. We're going to have a distance. We're going to have a rate. We're going to have a time. Now, keep in mind, I'm going to fill in the D column. I'm going to fill in the R column, but I'm going to let the D divided by R. I'm going to let the doctor tell me the time. I'm going to get that T by dividing D by R. So let's take a look at problem 2 here. It says the speed of a boat in still water is 15 miles an hour. Okay, now that sounds like a rate to me, 15 miles an hour. But what's this weird thing they're saying about still water? Let's talk about that in a second. It says the boat can travel 60 miles downstream in 2/3 the time it takes to travel 60 miles upstream. So it looks like I'm either going upstream or I'm going downstream. That's what it looks like. And that's what I did on the practice problems. If you look at Canvas, well, going upstream or downstream, I'm still traveling 60 total miles. Now, what about this weird 2/3? 2/3 as much time. Whenever you see 2/3 as much time or something like that, this is going to go into my equation. This goes into the equation. It does not go in my chart, but it's going to make itself known when we go to write the equation. Once again, I'm trying to fill in the D's, the R's. That's going to give me the T. And then I'm going to take all the stuff that's in the T column and I'm going to create an equation with it. So here we go. What is this upstream, downstream concept? Well, you guys know that if you're out in the water, you're either working with the current or against the current. Everybody who grows up by the beach has been sucked out in a riptide at one time or another. So when you are going downstream, that's when you're going with the current. So how fast is this boat going? It's going 15 miles per hour plus however fast the current happens to be pushing it. Then going upstream, well, I'm going 15 miles per hour minus the current because the current's working against me if I go upstream. Do I have the D column filled in? Yes. Do I have the rate column filled in? Yes. I'm going to go distance divided by rate. It's going to fill in my time box. So distance divided by rate equals time. The time it took to go upstream. Distance divided by rate. The time it took to go downstream. Now, here's the way we're going to write this equation. This equation turns out to look like a proportion. Get used to that. Whenever they say like 2/3 as much time, 1/2 the time, twice as much time, whenever they say something like that, we are going to end up with a proportion. Now, I know that the upstream travel is technically not the same as the downstream travel. I know that these are not currently equal to each other. They are not. If I'm going upstream, right, this is my upstream, this is downstream, I'm going to travel much faster going downstream. So technically, this number is smaller than this number. To make both sides equal to each other, I'm going to erase that little not equal symbol. To make them equal to each other, I'm going to say 2/3 as much time. 2/3 as much time means multiply by 2/3. If it said 3/4 as much time, I would multiply by 3/4. If it said 5/6 as much time, I would multiply by 5/6. So what I'm going to do now is I'm going to make this a little prettier. The 3 goes into the 60 20 times. 2 times 20 is 40. So now I have 40 over 15 minus x equals 60 over 15 plus x. And I can treat this like a proportion. It's a cross multiply, set them equal type deal. Now, I worked everything out ahead of time, and I want you guys to know that if you solve for x, you will get x equals 3. 3 what? 3 miles per hour. Remember, what did, hang on, I'm going to get a different color here. What did x actually represent in this situation? X was the rate of the current. So let me stop for a second, scroll back up. Let's analyze this. Question 2. Okay, here we go. Question 2. The speed of a boat in still water is 15 miles per hour. Okay, that's why I have 15. So that's to represent how fast the boat goes. The boat can travel 60 miles downstream in 2/3 the time, 2/3 as much time as it can travel 60 miles upstream. What is the rate of the current? I don't know. See, that's the thing I don't know. But I do know that if they say upstream, the current works against me. That's why it's negative or minus. If I'm going downstream, it works with me. That's why it's a plus in this case. So what I'm trying to get at is you're not experts at this yet, but you do have an idea of upstream, downstream, going there and back, etc. And I want you guys to understand that when you go to put all the ingredients together, the thing that's going to make up your equation is whatever happens to be in the column underneath T. Okay, let's let that sink in just a little bit there. Now, problem 3. The speed of a plane. Oh, now I'm in a plane. I'm not in the boat anymore. Now, I just want you guys to be familiar with this because what they're going to mention in these type of rate problems is something they call headwind and something they call tailwind. If you are in an aircraft and the wind is blowing at you directly, it will slow you down. That is slowing me down. It's called a headwind. It's kind of like trying to go upstream in a boat. A tailwind is when the wind is coming from the back and it's actually making me go a little bit faster. So this is like a plus idea, and this is like a minus idea. Let's look at problem 3. So here we go. There's a lot of noise here, but here's problem 3. It says the speed of a plane in still air is 450 miles per hour. Here they go with that still stuff again, still air. So it's going 450. The wind is blowing at 50 miles per hour from the east. Now I think that's okay. Is that blowing against me or with me? Is that a headwind or is that a tailwind? Well, let's read on. How far can the plane fly east and return in a total of 5 hours? Now look, 5 hours is the total here. So it's kind of like question 1, where they gave me, I'm going to go there, I'm going to go back, and then I'm going to have a total of 4 hours in my trip. In this one, I'm going to fly east. So here we go. Problem number 3. I'm going to let the doctor, the distance and rate, tell me the time. But this time, I'm going to be going against the wind in one direction. I'm going to be going with the wind in another direction. Now, headwind is against you, okay? It slows you down. So a headwind, that's always against. That's the negative idea. Tailwind is always speeding you up, so that's the with you, in your direction. That's a positive idea. I know that my plane had a certain rate. Let's scroll up again. The rate of my plane was 450 miles an hour. Now here's the part with the east and the west. If the wind is going 50, if I'm going into it, it's going to slow me down by 50 miles an hour. But if I'm going with the wind, it's going to speed me up by 50. Keep that in mind. Those are rates. So headwind, that would be like 450 minus 50. Well, what's 450 minus 50? That's just going to be 400. Then tailwind. 450 plus 50. That would speed me up by 50 miles per hour. So 450 plus 50, what's that? That's going to be, oops, I erased too much. 500. So let's get actual numbers there. Now I'm flying east and I'm going to return. I'm going to fly so far, but then I'm going to come back the same amount of distance. So I don't know how far I'm flying east and returning. I don't, but I know that the trips are going to be equivalent. Let the doctor tell you the time. It's D divided by R. It's D divided by R. What's in this column? The T column? What's in there? The stuff that's going to make up my equation. If I fly all the way east, I'm going there, and I'm coming back. It took me how many hours? 5. Remember, everything in your equation, everything has to do with time. I flew east and I returned, which would be the opposite, or west, but I got east and west equals 5 miles or 5 hours total trip. So I took this and I multiplied everything here to solve my problem. I multiplied everything by 2,000. That's what I used, 2,000. And then I canceled out stuff and I solved it. I got an answer of x equals 1,111, and it kept repeating, so it was an approximate answer, that many miles. Oh man, we're getting there. We only have one more example, and then I'd like you guys to look at the same exact problems that I have in this video. There's the assignment that you're going to do. There's the answer key, and there's my hints. So if you get stuck, at least I gave you some places to begin writing down your problems or your concept of what you should do. That's the best I can do if you are not in the classroom, is give you a list of hints. I hope that helps. Just remember, you won't be at home forever. When you get back to school, you can ask me for help through this. Okay, but make an effort. Do what you can to get this done. Here we go. Okay, number 4. I have one more example. Okay, here's the example. Jim can drive 480 miles in 3/4 as much time as Linda can. Okay, so here we go. I'm going to start. I have Jim and I have Linda. Those are my two people. And it said that Jim can drive 480 miles in somethings. 3/4 as fast? 3/4 as much the time as Linda. Okay, so guess what? They are both going 480 miles. Let's find out about the rate. Then I can use that to figure out what the time is. So let's look at the rate. Let's find it out. Okay. Jim's average speed is 10 miles per hour greater than Linda's speed. So Jim's speed is 10 greater than hers. I don't know what her speed is, but I know his is 10 miles per hour faster. Hey, it looks like I have enough stuff to have the doctor tell me the time. So I'm going to do 480 divided by x plus 10. Then I'm going to do 480 divided by x. And I know that Jim is not exactly equal to Linda when it comes, that's Jim and Linda. They're not equivalent yet, but I know that Linda would take longer. Why? Because she takes longer. She's going slower. Now, I'm going to multiply her by 3/4 because remember, in the problem, let's go back up for a second. In the problem, it said 3/4 as much time. What you want to do is you want to take that number and multiply it by whoever is going to take longer with respect to time. I'm going to erase, just going to erase that part right there. Now let's clean this up a little bit. 4 goes into that 120 times, 3 times. So what I'm trying to do is I'm trying to write this so that it's an easier problem. 120 times 3, that would be 360 over x. I am making this video and I hear all kinds of traffic in the background. Anyway, here we go. Let's cross multiply. And if we did, we'd end up with an equation where I get x equals 30. 30 what? 30 miles per hour. So how fast is Linda going? Well, Linda's going 30. How fast is Jim going? He'd be going 10 miles per hour faster, so Jim is actually going 40. Remember, they're going to ask you to find something in this problem, so what did they ask me for? They said find the average rate for each, or speed for each, so we did. Linda's going 30, and Jim is going 10 more than that, so 40. All right, so guys, that's my 4 examples. How do you do these problems? You chart them. How do you chart them? Well, you want to make sure that you got a distance column, you want to have a rate column, and then you're going to have whatever they're comparing. So variable here, but you're going to always take whatever's in the D, whatever's in the R, you're going to divide them to get yourself this T. Because remember, whatever ends up in this column here is going to end up in your equation. So for example, just going to show you, number 1 real quick here, it says a business consultant travels between 2 cities by plane in 10 hours less than it takes to make the trip by train. So I already know I'm talking about a train and I'm talking about a plane. Those are my 2 things I'm comparing. Now the distance between the two cities is the same. I don't know how far it is, but just because I'm in a train doesn't mean that it's going to be a different distance than if I took a plane. What's going to be different is how fast a train goes compared to how fast a plane goes. So my rate's going to change. Now, it says, blah, 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 the average speed of the plane is 480, the average... Okay, so here's what I'm trying to show you. Look, here's how my hints work out. Look at this hint. If you don't know where to start, that's what I did to kind of kick you in the right direction. I could then fill in the rest of this and do my distance divided by rate, distance divided... I could fill in the rest of this, and then it all comes down to this. If I'm in a plane, I would have to add 10 hours of travel time to make it the same as if I were taking a train. That's this example. So if you don't know where to start and you're confused, just think of it this way. You're always going to have to write a chart. You're always going to be doing D, R, and T. You are. You're going to fill in something for D, something for R. That's going to give you all this stuff. Then you're going to create some kind of equation to make sense of the entire problem. Okay, I know that that's a quick way to get through this, but all this work, all these worksheets, all this practice is on the Canvas page. So please check that out. This assignment will take you a little bit. So it's not due today. Please check the Canvas calendar to find out exactly when it's due. And if you need to, call a friend or text somebody or get in a Google Meet or something so that you can help each other out. All right, that is the end of this lesson.